Okay, so now we've got the C1 exam out of the way. Now we've got to concentrate on C2. So again, exactly the same format. What we're going to do is have a look at the 2016, 2015, 2014 papers. And we're going to go through it question by question. So the first one is all about geometric series. Now, geometric series, there's a couple of things to remember. First of all, that any term is going to be AR to the n minus 1. That's to find any term in the sequence. Then there's another thing to remember, which is the sum of the series, which is a then r to the n minus 1, then r minus 1. And we tend to use this one if r is bigger than 1. And then if r is less than 1, we use a 1 minus r to the n over 1 minus r. Because that way, if r is less than 1, this will still be a positive number. I mean, it doesn't make any difference, but these are things that we're going to use. So here, we've also got the sum to infinity. Now, the sum to infinity is if you kept going, your answer will get closer and closer to this. There's a over 1 minus r. So all these things are things that you need to know for this topic. So the sum of the first 4 series is 175. We've got a common ratio 3/4, so it says the sum. So we're going to use this one here, because this is the sum of a series, and we're going to use this one because r is less than 1. So if we do that, we're going to do, even though it says show that a equals 64, we can't use 64. We've got to end up with the answer a equals 64. So it's going to be a lots of 1 minus the ratio, which is 3/4, the power of n, which in this case is 4, all over 1 minus 3/4, and that equals 175. So that's going to be our first step. And then it's a matter of trying to expand it. So 1 minus 3/4 to the power of 4. So you just type that in. And that's going to be 1 over 81 over 256 over 1/4 equals 175. Times both sides by 1/4. So 175 times by 1/4. And we end up with a equals 175 times by 1/4, which has got rid of this, and we divide by the bracket, so over 1 minus 81 over 256, and that equals 64. So that's how you show it. You can't use a equals 64, substitute it in, and then get the answer. They won't give you that one. Right, next, find the sum to infinity of the series. Now, as we said, the sum to infinity is this thing here on the right. So what we need to do with that is we just need to substitute in a new value of a and our value of r. So it's going to be, so the sum to infinity equals 64 over 1 minus 3/4. 1 minus 3/4 is 1/4. So 64 divided by 1/4, which you can do on your calculator, or 64 times by 4 over 1, which equals 256. So you've got 256 for this one. And the difference between the 9th and 10th terms in the series give rise to 3 decimal places. So what we're going to do here is the 9th term is AR, so we're going to use AR to the n minus 1. So for the 9th term, it's going to be 64 times by 3/4, to the power of 9 minus 1, so that's the power of 8. And for the 10th term, it's going to be 64 times by 3/4 to the power of 9. And if we're going to find the difference, we're going to do this one, take away this one. So in terms of your workings, what you could actually do is do that one, take away 64 times 3/4 to the power of 8. Do that on your calculator, and then if I just pause the video, I can tell you instantly what we get. And putting it into the calculator, it gets minus 1.602, because obviously this one's going to be a bigger term than this one, because it's getting smaller each time. So if we get minus 1.602, we can actually say the difference is 1.602 to 3 decimal places. So that was the 2016 one. 2015 paper. All the terms of a geometric series are positive. So that, if we read the question, that's probably going to come back to us. And the sum of the first two terms is 34, and the sum to infinity is 162. Find the common ratio, find the first term. Now, usually, these two questions are marked as 1. So what we're going to do is we're going to make two simultaneous equations. So the sum of the first two terms. So what we can do, to make it slightly easier, is the first term is going to be a, and the second term is going to be AR. So a plus AR equals 34. And then the sum to infinity is 162. So that's going to be a over 1 minus r equals 162. And now what we've got is we've got two equations which we can solve simultaneously. So if we factorise out for the first one a, it's going to be a bracket 1 plus r equals 34. So if we move this to the other side, we've got a equals 162, that's 1 minus r. And if we move this underneath, that's going to be a equals 34 over 1 plus r. So we've got 34 over 1 plus r equals 100, if we multiply this out, 162 minus 162 r. Then we can bring this up to the right hand side. And if we do that, we get 34 equals 162 minus 162r times by 1 plus r. So 34 equals, and using the smiley face method, 162 plus 162r minus 162r minus 162r squared. Then 162r minus 162r, this cancels out. If we move this to the other side and move this to the other side, we're going to get 162r squared equals 162 minus 34, which is 128. So we've got r squared equals 128 over 162, which if we simplify that fraction goes to 64 over 81. And then we've got to do the square root of it. And again, it says all the terms of geometric series are positive. So when we do the square root of that, usually we'd get plus or minus 8 over 9. But because it says it's only going to be positive, therefore the ratio is going to need to be positive as well. So r equals 8 over 9. That's going to be the common ratio, and then we've got to work out what the first term is. So if we then substitute it into this here, that's going to be, so no, we don't know what a is, but a over 1 minus 8 ninths, so that's divided by 1 ninth equals 162. So now what we can do is times both sides by 1 ninth. So 162 times by 1 ninth, or divided by 9. So a will equal 18. And that's going to be the first two things there. So now we've got a different geometric series. So if we clear the screen there, a different geometric series has a final term of 42 and a common ratio of 6/7. Find the smallest value of m for which the sum of the first n terms of the series exceeds 290. So I think the easiest way to attempt this one, rather than have a look at inequalities, actually set it equal to 290. So we're looking for the sum, so that's going to be a, and we've got the ratio which is less than 1, so 1 minus r to the power of n over 1 minus r, and that's going to be the sum of a series. Then what we do is we set that equal to 290, and that's going to equal 42 1 minus 6/7 to the power of n. Remember to put that in brackets, all over 1 minus 6/7, which is 1/7. So then what we can do is divide both sides by 42, times both sides by 1/7, and then if we do that, we get 145 over 147, and that'll leave us with 1 minus 6/7 to the power of n. So now the thing that we're looking for, the n, is on the right hand side, and that's negative. So if we bring this over to the other side and we take away 145 over 147, we're going to get 6/7 to the power of n equals 1 take away 145 over 147. Remember, we can write 1 is the same as 147 over 147. So if we take away this, we're going to get 2 over 147. So now we've got to find n. N's a power now. So this is where we use logs. So we're going to use logs of both sides. So if we do log to the base 10, because that's the button on your calculator, of 6/7 to the power of n equals log to the base 10 of 2 over 147. Then with the log laws, we can bring this n down to the front. So that's going to be n log to the base 10 of 6/7 equals the log to the base 10 of 2 over 147. And the thing we're left with, we divide. So it's going to be log to the base 10 of 2147 divided by log to the base 10 of 6/7, which 27.88 if we round it. Okay, so it means that the 27.88th term will equal 290. Going back to the original part of the question, so this equals 290. So therefore, if you want it to exceed 290, what we need to do is find the next term up. So it's going to be the 28th term. And that's how to do all the stuff on geometric series over the past 3 years.